So it is my pleasure to introduce kind of my partner in crime. When I first got introduced to semi-ODE, we were at a conference together and worked on a few things. And so it's nice to see that she's now at Texas A&M University of Commerce. And so Aditi Ghosh, please, the floor is all yours. Take it away.
Thank you, Terence, and welcome everybody to this session. So today I'm going to talk about one of the few problems that I think most of the mathematics departments nationally are facing. And based on that, I have put this topic forward, building capacity and collaboration for undergraduate research. So I am currently in Texas A&M University Commerce branch, and I joined the mathematics department in August 2021. I'm talking about the mathematics department that I have seen here in this department as well as my previous department. And what I hear from my colleague is the problem of student enrollment in mathematics department as well as student retention. I do not know how many of you, like Jean and Terence, you would also kind of enlighten me in this. Do you have similar or face similar problems in your department in the last few years? Like you are losing enrollment in the mathematics department. I mean, it's not like the number of students it used to be 5 years before or 10 years before, rather than we are seeing that there's a decline in the population. So to me, yeah, right? That's the same issue. Yeah, and I also hear from my other colleagues that they are facing a similar type of student retention and enrollment problem, especially in the mathematics department. So the question is like, why does it happening? Partially the answer is we are losing our students to the computer science department, which is growing, and we are shrinking. And the fact is that makes me wonder, why would like mathematics fall behind in terms of getting students? Is it the job opportunities that computer science can offer more and mathematics cannot? That's where I drew my attention to. And that's where I think like my focus of today's talk is. So when we talk about computer science and job opportunities, are we lagging behind in that area that we are not able to convince our students enough that mathematics also gives you a similar, I would not say similar, but also a opportunity and growth in your job? So that takes me to the slide that what we can do to kind of, address this problem as a faculty. In our department meetings, we talk about this, we talk about the school hiring people or agencies to increase enrollment and other sorts of strategies. But what as a faculty we can do to contribute towards a solution to this problem? And I think we should address at the very stem, like the student makes the students aware of the opportunities. Especially, I think the last 2 years, the COVID, last 2.5 years have actually opened our eyes that what models can do. We have been hearing predictions since March 2020, February 2020, that, okay, this is the number of infected cases. And then once we had done with this projection phase, we came with the phase of vaccine. How was the vaccine going to solve or control the spread of the disease? And even it's still there. What is the effectiveness of a vaccine in controlling the disease? So I think this has opened the doors towards the health industry, where we see a lot of applied mathematics coming into play. For example, we were not even aware of, talking in terms of a layman, we were not even aware of reproductive number before 2020. Many of us. I'm not talking about like people from mathematics or science, but many of us were not even aware of reproductive number. But thanks to COVID, I think 70% of our population have heard this word now, reproductive number, and what does it suggest? Not the meaning, but its application for sure. So I think when we have this, we now know what the health industry is looking for. We are looking for students who have the knowledge of logic, who have the knowledge of data, who can solve practical problems, right? So the question is, we need to make aware to our students that mathematics is not only typecast in the traditional way of teaching, but it's real practical application that goes beyond the classroom, and it spreads, how it spreads in the industry. So that's my first thing. What I do is when I take my pre-cal class or my calculus classes, I talk to my students about what I do in research and what are the things that are happening, that are cool things that are happening with the use of mathematics, and what my current students are doing, and what they do to project their research. So I make them aware of the fact that mathematics is not just some formulas or stuff, but it also goes beyond that, and the application of it in health industry, in pharmaceutical industry, in finance. So the awareness comes from my very calculus classes. And then once, I think like talking about these things, I can at least tap at least 10% of my students' attention, who come and then ask me, oh, I'm interested in this, I'm interested in that, I'm taking these classes. And once you get that attention, I talk to my students about the exposure, like what you should be doing in order to get exposed to this type of opportunities. I think, and when we advise students, I think we as a faculty, we also advise students. When I advise students, I make sure that I do not tell my students just to focus their classes in mathematics department, but also to get equipped with a little bit of data science, enhancing their programming skill set. And maybe if they're interested in social sciences or biological, take some of them, because that gives you a broader perspective of realizing the problems, the real life problems. And I think this kind of helps my students to understand the importance of, in today's world, the importance of interdisciplinary work. It might not be research, but the importance of having knowledge in things that are relevant in today's industry. So when I get that, and I started going to take my undergraduate classes, be it ordinary differential equation or mathematical modeling and simulation or applied mathematics, any sort of courses, numerical analysis, I start tapping the interest of my students to projects which could be open-ended or which are problems that interest my students, not me. I tell them, you can tell me what interests you and I would learn it from you. So in my mathematical modeling classes, where I had several collaborations with my students, I invited projects of their interest, and then I learned from them. Every bi-weekly we would be holding sessions to kind of discuss the progress of each project. And I think after we finish the class, because in a semester, to be honest, it's not fair enough to expect a student to come to a solution of an open-ended problem. But if the student is interested enough, they pursue it in the summer. And then I think like you can delve deep more into the research. And successfully, I have published, which I'll come and talk about in my next slides, with many of my students. So some of the open-ended projects resulted in publication in peer-reviewed journals. Some of them ended in just writing a report for scholarship. So this is how I engage my students in class and out of my class, working on projects and persuading them and telling them to, take graduate studies so that the opportunities becomes wider for you. And the other thing that I believe while working with students is, you give them ownership of the project. You tell them what is your interest and how you want to work on it. And then once you get them into the problem, you hear it from them and guide them towards it. I will not tell, okay, this is in my mind, this is the method, this is the model that I would use, but I would rather tell them, can you explore a few models and tell me which one do you think would be suitable for this particular scenario? So that's what I would do to give them the ownership. And once they take the ownership, actually, then they feel that they own the problem and they look more into it. So it's much more than an exam can teach. So I always prefer in my applied mathematics classes to give a project-oriented form of assessment. And then once a student gets done with the project or have some particular results, I strongly encourage my students to, kind of present it in an undergraduate research. So there are few forums that I particularly tell my students to present it through poster or through talk, and then make a network out of it. They have to grow out of me now. So that's what I do to kind of I introduce my collaborators to them so that they can work with them also. And then this has made a few of my graduate application of my students much more stronger. I have students working now, joining their PhD in Northwestern University of Minnesota last year. So talking about these are some of the students that I have recently worked with. Dominica, she has been my MTBI student. I met her in 2019 in MTBI, where we worked on a project. And we did not stop there. We continued even after the summer workshop. And then she's still working with me today, but I'm going to talk about a project that I'm working with her. And she did an intern last summer in Max Planck Institute in Germany. And then Christine, she was my student in University of Wisconsin, Whitewater. She's now in University of Minnesota pursuing her grad studies in applied mathematics. I worked on her on liver injury, which I'm going to talk about in details. And she was interested in doing interdisciplinary math. And she now, I think, is doing computational research in University of Minnesota. And Claire was a double major. She was a major in physics as well as a mathematics major in University of Wisconsin, Whitewater. And I published with her on a project that we did it in class and we finished it. So talking about the project, these were some of the projects that I did with them. I think this was a project that I did with an undergraduate, Isaac. So it was on role of alcohol consumption in acetaminophen overdose. And this was the work with Isaac Berger, who had been a biology major. Mark, he was not a mathematician. He was a biology major who worked with me on a summer, and his interest in biology, I think, helped him understand the mathematical model and use the data to help me to come to a conclusion on the role of alcohol. So this was published in JTB in 2021. And then the work that I did with Claire, it was a project in class where we started on, they were not able to come to a consensus on a particular mathematics project. And I told them, like I have been working on liver injury, and one of my collaborators have asked me to look into ischemic liver injury, which is a liver injury due to deprivation of oxygen in the body. Would you like to take an interest in it? And then they dug up the whole research, and in the class itself, they were done with the model, the numerical simulation. And then I think after we did the class, when it was fall 2019, we came up with the implication or validating the data to the model, basically. And this one resulted in PLOS One, which was quite a reputed journal for an undergraduate to publish. And then there were several others, which I was talking about with Dominica. This project, Dynamics of Prime Proliferation under the treatment of interferons and chaperones, was a part of my MTBI project with them. They completed after MTBI, and we now work on a different project on COVID19 transmission in closed care facilities. So this was a work with Dominica, and then with Christine, I think we're still working on a liver injury project. But as I said, I believe in promoting my students. I introduced Christine to my collaborators, and I think we both worked on this data-motivated time-dependent estimation of transmission rate. And we published this one again in, I think, 2021 in a tropical health medicine journal. So all these students that I have worked with right now are either doing graduate studies or is involved in R&D in industry because of their exposure to research. So the other way of promoting my students, what I do is I am involved with IBA, which is an institute housed at Illinois State University for undergraduate, or not only for undergraduate students, but also for faculty who are affiliated with undergraduate universities or four-year colleges. So they have a REU model summer workshop called CURE, which is a cross-institution undergraduate research experience. And the 2021, I was a co-organizer of it, and we had students from across this four-year colleges or undergraduate universities, where we had 4 to 5 projects where students presented, worked in CURE under faculty guidance in a group, and they presented in the BEER conference, which is also housed at IBA, Illinois State University. So last 2 years, BEER was virtual because of COVID, and students, both students and faculty can present, but I tell my students to either do a presentation in poster or give a talk. So this is how I tell my students to kind of, if you have done something, you should tell it to the world. And then another collaboration that I did with a colleague of mine very recently, where we talked about reproductive numbers, but in the context of tipping point, which is from the book of Malcolm Gladwell, Tipping Point, how tipping point serves as an inspiration for building a narrative for reproductive number, actually. So it's not the usual mathematical formulas that we have come up with, but we have tried to correlate math to a context where it is understandable even for high school students. So this is in publication. It's not published now, but I think it's under Springer publication. Hopefully this year it will see the light of days. And talking about Domenica's work this time with me is on a COVID-19 transmission in close contact facilities. So as we are all aware, during 2020, the first half of 2020, we were hearing about a lot of cases in close contact places. For example, the Diamond Cruise was one of them, where it was a super spreading event, especially. Then the medical centers, and then the close contact facilities in terms of the long-term care. So talking about the long-term care, what we thought about, we came upon this article in King County, Washington, in the beginning of March, where a lot of outbreaks, I think, yeah, Washington, I think Jean could relate to that. I think she must be aware of the situation, yeah. Where in February and March 2020, a lot of cases were getting reported and was getting media attention, partly due to the fact that this long-term care facility houses senior citizens who are more vulnerable to COVID. So these were the data that we were kind of looking at in February, March, and what we found is that the population structure is, the subpopulation is visitors, healthcare personnel, and residents. So looking into this data and the trend of the number of cases, we tried to build a model. And this model actually now consists of, what is the new thing about this model is we have incorporated environmental transmission into this model. But most of it, in the SIR model, we do not have that for disease spread. And then not only environmental transmission, but also what we tried to do is we introduce optimal strategies for non-pharmaceutical interventions to control the spread of this disease. So we divided our subpopulation accordingly: residents, healthcare, and visitors. So the residents were the people who would be confined in the long-term care facilities. They do not have movement outside the long-term care, but healthcare staff workers could come in and go out, and they could also move within one facility to the other. So they were mobile, and the visitors who would come from outside during a certain time of the week for a certain period and can visit the residents. And then we applied, as I mentioned, the optimal control to control the spread of the disease. So the population we had the healthcare residents as well as the residents as well as the healthcare staff divided into the SEIR categories. And then the visitors who were exposed to COVID-19 but were not aware of it. And then the environmental transmission was captured by the fraction of contaminated air in the environment. So this was the structure of our model, and I'm not here to kind of go in more into the mathematical part of it, but to just giving an overview. This was the state model that we came up with, and this was our estimation coefficient. The beta estimation coefficient, transmission estimation. And these were the parameters. Some of the parameters we could find it from the literature, and some of the parameters had to be taken from estimated rather. So we considered here 3 cases. The first case was there was no super spreading event happening within the subpopulation. The second case was the super spreading event was happening to the residents. If one of the residents was infected and was unaware of the fact, they could be potential super spreaders. So this was case 2, and our case 3, when we considered super spreading event among the healthcare staff. Remember, the healthcare staff was more mobile compared to the resident. So these were the three cases that we came up with. And accordingly, we defined our transmission coefficient, lambda R and lambda H, where R stands for the residents and H for the healthcare workers. So this theta 1 took care of the proportion of the residents, and theta 2 during the superspreading event, and took care of the healthcare superspreading event. And we introduced U1, U2 as a control factor through non-pharmaceutical intervention, especially using mask, controlling through mask, and then cleaning the environment by U2. So we introduced our control factor in our transmission coefficient. And once we did that, we had to come up with our goal to minimize the exposed and infected population and the cost associated with it. So this was the functional that we came up with. Now, mind you, here are the costs, here are the weights associated in bringing down the infection of the residents, of the exposed and the infected population, and beta B, the B's are the cost, the weights associated with the cost for implementing the intervention. Now, coming to this fact, like during the numerical simulation, I mean, this is a very typical optimal functional that we come up in a book when we maximize or optimize a function. But we do not realize when the book talks about, we do not realize what are the method involved in estimating or coming up with an initial guess for these weights. Remember, like when we have to simulate it, right? Like for simulation, the initial guesses are not given in any book. So this was a struggle that we faced with my students. Like, how do we come up with the initial weights? There's no particular method for it. And your numerical simulation would depend on the weights particularly. So this was one of the stumbles that we came up with my students, and we have to dig up a lot. I think we consulted Susan Lenhart for this to give us an insight onto it. And I think then we started working onto it. So this was not an easy, although it looks like a one-line formula, but implementing it into the code was not an easy job. And talking about the result, so we calculated our reproductive number. And if you look into this, rightfully so, what we saw that, yes, case 1 was a non-super spreading event. The reproductive number was low compared to the super spreading event. But the interesting fact is, in the case 2 and case 3, we consider super spreading event. But we saw that case 3 had a higher reproductive number compared to case 2. And why do you think so? This is because of the fact, remember, case 3 was concerned with the healthcare workers. Healthcare workers were more mobile than the residents, and that contributed to the more spread of the disease. So this was very well captured in the model. And then we implemented, as I said, we implemented the control factor U1 and U2, and the control could kind of help us see in our results that if I now look into this resident population and the healthcare population, so these two, the red and the purple one, were applied with optimal control, while the green and the blue shades did not have optimal control applied. So we successfully see that implementing the optimal control in the model was bringing down the peak for the cases. So that means intervention were having an effect on bringing down the number of infected cases. Both we saw it in the residents as well as the healthcare workers. So we have built things successfully, but I mean, till now, the results, rightfully so, were kind of matching or validated with what we expected. But there, as I said, there were a few stumbles that we need to work more on. Do we find a similar pattern of transmission coefficient in other close contact facilities? For example, the diamond cruise that we talked about, was the transmission dynamics similar? Or it could be a little bit different. So these are some of the things, and the weights, how to study the weight, or the initial guesses to work on to come up with an effective simulation result. So these were some of the things that I think we need to venture more to kind of make our conviction about our model greater. And there's, as I said, the future work also have to be on different other close contact places to study the transmission dynamics there, and maybe draw a pattern if there are in the spread of the disease. And applying the model to the data of King County, Washington's King County's long-term care facilities. So these are some of the works that we tend to do. But right now, this work is under the process of editing and writing, and hopefully within a month, if my time permits, I can submit it. And let's see what the future holds for this project. So this is some of the thing that I have done with my students in the last 3-4 years to kind of encourage people into mathematics. And I think coming and joining in this new school, I'm taking a similar effort in kind of bringing courses, in bringing interdisciplinary courses into the trajectory to make students aware of the fact that the opportunities are not only restricted to computer science, but mathematics actually gives you a wider perspective of it. If you have the skill of programming or coding, and if you have the interpretation of how to interpret a social science or a practical problem and formulate the mathematics out of it, the chances are similar. So that's what my hope for the next few years, to make the department a little bit more stronger in the area of enrollment, but let's see what happens. I think I'm ending my time right now. So you have any question for me?
Yeah, thanks, Aditi, for that. Yeah, I think we do have a couple of minutes for questions. If anyone had any that they wanted to ask, you can also throw in the chat, and I'll be watching the chat here as well.
Yeah, I didn't hear the look at the chat. Oh, Jean has a question. Also means we expect our enrollments. Yeah. No, but like you're talking about data science, but what I see is, even though if you need to, if you have a data science stream or a data science certificate course, I still feel that just taking the data science is not enough. Like, you will take some computer science, you also have to take math courses, right, to get that logic, to get that mathematical maturity. So I will not say like, data science department or something, but I would rather have a data science certificate course in the math department itself, in collaboration with other departments, so that we can retain our students. That's what I would strategically try to do.
So right now we have 2 pure math majors. We have a small and a large math major. It depends on how many credits you want. We have an applied math major, and we're bringing on a data science major that's housed in the math department. Yes. Although there's another one that's housed in the computer science department. And of course, both data science majors, the computer science students have to take math courses, the math students have to take data science courses. But the problem for us is that our senior level math, especially the pure math classes, don't tend to get a lot of enrollment. And we're worried that we're basically going to kill off those programs because a bunch of those students will go to data science. But that was just back at the beginning of your talk when you were talking about that. So what I would really be interested, I know you've done a lot of your thesis research. So I knew Aditi back at Texas A&M, where she was a graduate student and I was non-tenure track faculty. I know you've got a lot of expertise that probably came in from your thesis work, but can you tell me a little bit more about how you kind of get started with the projects and getting some of the knowledge that you would need to get going on some of this? I mean, I'm speaking as somebody who's in a tenure track position at an undergraduate institution, but I was out of the math research world for a number of years, and there's stuff that I can do, but there's also places where I'm just like, I've been out of this world for so long, I don't know how to get started.
To be honest, Jean, like answering firstly that as a graduate student, you might have known my experience. My research advisor, I didn't have much enthu on that. So I still now kind of hear from him. So I did not quite enjoy the area that I was working with. So that's where my struggle started after I graduated. I was not willing to kind of, give more time to the area that I was designated at. And then I made a mind to kind of shift my area. So during my postdoc, I think I went and asked my supervisor that, I'm interested in doing more practical application of mathematics. Can I have a project based on that? And that's where it started. So I was doing a separate project, and then I asked her, can I, on a side time, can I walk into a different project? And then she gave me a project based on mathematical biology. so there, I think my journey started from there. And what I started doing is I did not have any knowledge on mathematical models at that time. I started learning, reading a little bit. And I think then I went to do a postdoc with Christopher Riemann in University of Idaho. And he introduced me to the liver injury project that he was doing at that time. So I think because of my work, I started learning stuff. So that's how I started working on it. And then when I joined as a faculty in University of Wisconsin-Whitewater, I started teaching mathematical models and simulation and other applied mathematics courses. And I think I self-taught myself. So that is where I began. But I think like about the projects, how I start is like, especially, every year, if you have to take a course, you do not have a resource or project for students. Like, okay, I have this and that. So I tell them, first form a comfortable group. If you are peer or friends, form your group, cozy group. And then you tell me what interests you. And then let's discuss what we can talk about. Somebody tells me, oh, I'm interested in ecology, doing a problem in this. Somebody says, oh, social media interests me because they have a computer science major or something. So then I told them, okay, if you have this problem, nowadays fake news is quite a relevant topic. People are writing in blogs and all these things. The election has kind of exposed it. So why don't we take this one? So the current scenario, actually, like whatever I read, I kind of tell them, like the tourist problem in Wisconsin was we are facing, the fishing stuff. So those news that I collect and that remain in my head, or my students think, they're interested in it, we discuss and then we think, okay, let's do something based on that. So as I said, some projects closes after the semester because we don't have enough time. And some students who are really motivated, who want to capture it more, they educate me. Rather than me educating them, they dig it and they come and tell me, oh, this and this, we got this data from the project, how do we implement it? We read it again. So they educate me more than I educate them. And this is how I think like we kind of come on a project and finish it out. I mean, I do not have a formal training or anything, but I think the other thing that have helped me is forming collaboration with IBA, Intercollegiate Biomathematics Alliance. I found a group of similar like-minded people who may be working in R1 universities, but they take interest in undergraduate research. They help you out with that. So I think like IBA helped me in kind of giving my students the platform, or in me collaborating with people around to kind of get my projects done or share my projects with my students. So that few things I think like have helped me in getting projects. I don't know if I had the right kind of answer for you, but this is over the years this is what has worked with me.
Awesome. Well, I think that actually takes us through the first session here. And so thank you guys for coming. Thanks, Aditi, once again for your talk. I actually picked up a few ideas of some things I'm doing with some students that I'm gonna have to read up on and borrow here. And so that actually concludes the session for this room, but there are talks going on in the other rooms. And so I'm actually going to hop over to one of those myself. And so it's great catching up with you as well, Aditi. I think this room will be open, of course, if you guys want to chat a bit more. But yeah. Please enjoy the rest of the conference, and hopefully in a different capacity, perhaps in person one day, we'll see each other again.
Yeah, sure. I would hope so.
All right. Take care.
Thank you all.